Hi, welcome to video 95. This video is on graphical inequalities, otherwise known as regions. Now, the keywords I've got for you here are inequality, satisfies, and region. An inequality is a symbol that's used in maths to show something is not equal to. The word satisfies, basically in this context means makes mathematical sense. And I'll help you understand that a little bit further when I do the examples. And then the region is the area of the graph that we're going to shade in. That is the bit that we want to identify, all right, and we'll call that the region. To represent a region, you must understand how to graph equations of lines, and if you don't know, then please go and watch the equations of lines video that I have made for you. You will be given some inequalities to draw in the grid and choose an area to shade that satisfies all of them. Draw the lines in the grid, and you've got to be really careful here. Solid if it includes the value, so if there's a little line under the inequality, then you're going to draw a solid line, and dotted if it does not include the value. So if there's no line under the inequality symbol, then you draw a dotted line. Okay, either way round, doesn't matter what way round the arrow is pointing. All right, decide the bit the inequality satisfies until you narrow down to one area, and then you're going to check using substitution just to make sure you've got the right area identified before you shade anything in. So graphing number one, let's have a little look and zoom in to this. Graph the following inequalities and shade the region. I hope I'm not covering too much of the graph there with my mug on this video, but we will see what happens. So graph the following inequalities, shade the region. Y is less than or the same as -3. So what we do is we think of the equation y equals -3 and we draw a line there. Now this is an easy one. All right, there is -3 on the y-axis. Just get my line tool. And I will draw a solid line because it's including that -3. Now we're interested in everything that is below that line, all right? We can forget about everything above that line, all right? We want everything less. Y is less than or the same as -3. So it's got to be on the line or below, all right? If that was the only inequality, we'd just shade that region in, right? There's not, there's two more. X is less than 2. So we're going to draw a line down X is equal to 2, right? But we're not going to draw it as a solid line this time because it's less than, all right? So we need to draw a dotted line, which is a little bit awkward to do. So I'm going to draw a few lines like this. You'd have to draw it a little bit better than what I'm doing, all right? But that'll do, that'll do. So I've got my dotted line that's going on there, right? And there is that's that inequality. Now we're interested in anything that's less than this value of x equaling 2 or x is 2, right? So it's everything this side of the line, everything to the left of it. So at the moment we've narrowed it down to this section here, this rectangle down the bottom left hand corner of the graph, right? Now we've got to deal with this last one. So what I'm going to do is I am going to pop in some values of x, because this is a y equals mx plus c style question, all right? We might need some values of x to then just chuck in here and figure out what the y values are. So quick little table, 3 values, x and y. You can just sketch this yourselves, or you could do it without it, but -6 is the first value of x I'm going to use. Then I'm going to put in 0, and then I'm going to put in 4 because I know that 6 won't work, right? So y is the value of, if -6 goes in, sorry, so -6 is in there, -6 plus 2 is -4. All right, 0 goes in, that's going to give me the positive value of 2 if I substitute 0 in there, and then 4 goes in, I'm going to get 6. Right, now what I'm going to do is I'm going to plot those points with the thingy. 6 minus 4 is there. All right, and then we're going to go with 0, 2, so that's there. I could just use those 2 points, but a third one just to be safe. 4, 6 is there. Now they should all line up in a nice solid straight line, not a solid straight line actually, because it's less than this. So we actually need to do a line that is dotted. So we're going to go and yeah, they all line up nicely. So just going to do my dotted line, which is a bit awkward to do, but we'll manage it and we'll get there. There we go. So there's my dotted line there. Now y is less than x plus 2. So this is probably the tricky one to figure out. All right, we narrowed it down to this rectangle here, right? So we're either this tiny little triangle here or this shape that is made by the 3 lines intersecting each other here. So that's a 1, 2, 3, 4, 5-sided shape. Has no name, just a 5-sided shape. It's a irregular pentagon, effectively. So we've got this little triangle or this irregular pentagon that we are going to shade in, either one of these two bits. Let's decide on a the region that satisfies all three. So it's got to make mathematical sense in all three. Let's just choose a coordinate, right? So let's choose this coordinate value here, right? Because that's the value of -1, -4. Right, now the only one that we really need to check it in is the last one, right? So let's see if it makes sense. So we're going to take the value of x equals -1, -1 plus 2, all right? What is -1 plus 2? Well, it is 1, all right? And then we're going to see what that value of y is, which is -4, right? Now -4 is less than 1. Does that make mathematical sense? Is that true? Yes, it is. All right, -4 is less than 1. So it is this region that we want to shade in, right? Because it would make sense in the other two. We've figured that that's fairly obvious, all right, that it makes sense in the other two, but I'll show you anyway. All right, it's that region that we want to shade in. So you could do it nice and neatly if you want, but you only really need to kind of just make it really obvious that it's that region that we're shading in. All right, let's check that -1, -4 business in the other inequality. So x is -1. -1 is less than 2. That is correct as well. And then -4 is less than or the same as -3. Well, -4 is less than -3 because the y value is -4. So it worked in all three, and we know for sure that we've shaded in the right bit of that graph. Okay, that is the region that satisfies all three inequalities. All right, so it's a tricky little topic. But at the beginning, it's actually pretty simple, isn't it? Just draw the lines of the equations, get them in there. If you get them in there, you're picking up marks anyway. All right. Now let's have a look at the second question. Right. Zooming into that. Graph the following inequalities here. So same thing. Got to shade the region that satisfies, just different inequalities to represent. So this first one, we've got x is the value of, and it's between these two values. All right. So you're going to draw two lines to represent this one. One of the lines is going to be solid, one's going to be dotted. So at -4, let's go to a -4 on the x-axis, and that's going to be a solid line. So I'll get my line tool back up and draw a solid line through there. And then we've got less than 2, so go to 2. So it's got to be a dotted line again that goes through this particular part of the x-axis. Then we've got this inequality to deal with, so that's the first one done. X plus y is more than or the same as -2. Well, we can do the covering over with the finger method here, all right? And you could cover over the x and think of that as being equal to 0, right? And then that's y is more than or the same as -2. So y equals -2, effectively. So what would that have to be? All right, well, that would have to be -2, yeah? -2 is equal to -2, isn't it? Right, so -2 on the y, right? And then -2 on the x as well. So we'd need -2 on the x. So we'd join those 2 points together. And that is going to be a solid line going through there. So I'll just draw it that way to start with. And then I'll go from there and I'll draw it down that way. Right, and we've got that solid line that's going through there. Now that's everything that's more than this line. So everything that's above this line in this section here. So we're between the 2 points or the 2 lines that I drew originally, right? And then we're everything above that line. We can check that in a minute with a coordinate value that we want to. Okay, now y is less than 0.5 x minus 1. So half x minus 1. That's our third inequality. Now we might need to just draw a little table again of x values and y values. And if I get the freehand tool, that would help. So x and y. And let's just take 3 values again. So let's take the value of, and we don't need to go further than that really, but we could go to -5 if we wanted to. But I'm going to go to -4. There's our value of x. I'm going to put in 0, and then I'm going to put in 3. Just so you can put in any values and join any 3 points up. So -4 goes in here. Half times by -4. Half of -4 is -2. Minus another 1 is -3. 0 goes in there. So that would become 0. 0 take away 1 is -1. And then 3 goes in there, and that would be 1.5. And 1.5 take away 1 would be 0.5. So we've got our 3 coordinates which we can plot. -4, -3. So plot that one there. 0, -1. and 3.5. 3 is at a half, which is there. Right, now let's join that up with a dotted line this time, because we've got no little underliney bit on the inequality symbol. So, oh, that's, oh, I thought it was going to go wrong. Right, just doesn't want to, just wants to draw it flat for some reason. I don't know why it's doing that. That's being really, really funky. There we go. That'll do us. Rather than cause me more pain. And continue. There we go. Right, so we've got that should be a very straight dotted line, but it's not perfect. Anyway, let's get the hand tool back. Now, let's decide on the area which we think it's going to satisfy. So I think it's probably going to be this bit, right? Because we're less than this line, we're more than this line, and we're in between these two lines. So I think it's that area there. So I'm going to choose that coordinate and see if it works in all three inequalities. Right? That coordinate value is 1, minus 2. And this is what I did in the last question. So you didn't quite understand what I was doing in the last question. That is that coordinate there. All right? And we'll see if that works in all three. So if y is minus 2, that should be a minus 2 there. So minus 2 is less than half multiplied by 1. So that would be half, 0.5, minus 1. So 0.5 take away 1 would be minus a half, minus 0.5. Now is that mathematically true? Minus 2 is less than minus a half. Yes, it is mathematically true. Minus 2 is less than this. Alright, so I'm happy with that for that inequality, for the last one. Let's take this point and see if it works in here. So x is 1. Just do the working out up here. 1 plus minus 2, right? 1 minus 2 is minus 1, right? Minus 1 is more than or the same as minus 2. Now that does make mathematical sense, all right? Minus 1 is more than minus 2, all right? And that might be difficult to understand, but go back to the number section and think about positive and negative numbers there, right? Adding them, subtracting them is tricky. It's a tricky little thing, especially when in the context of a question that's quite complicated in itself. And then we've got to see if this value of x here is working for these ones, and it clearly is, right? 1 is definitely between the values of minus 4 and 2, isn't it? All right, so it is that area that I'm going to shade in. All right, and let's just get that shaded, and that's it. That'll do. We'll have that. There's our area. That's our region. All right, lovely, fun, isn't it? Now, this last question here, we've got just another 3 different types of inequality, and then we've got a list, so the coordinates of all integer values for r. Okay, now r is the region. Graph the following inequalities and shade the region r. Right, I just give it this letter, big letter R, that satisfies all 3. So y is equal to x. Right, that's the line that we could draw there. So y equals x, that's an easy one. Alright, I told you this would come in handy in the y equals x video that I did, which was graphing equations of lines. That would come in handy. X is more than 2. There we go. So there's that one. We'll have that. More than or the same as 2, solid line. And then another solid line, so don't have to worry about drawing any dotted ones. So that would be finger method. Put your finger over x and pretend it's 0. So y equals x, 6 equals 6. And then do the same for the y, and then you'd see that 6 equals 6. So just joining the 2 6's together on the x and the y axis. There's the quick way of doing that last one. So we've graphed those 3 things, quick ways of doing them. Just decide on the area that actually makes mathematical sense. So list the coordinate values for r. So we're more than or the same as x, so anything above this line, so this section here. We're anything above, again, here, for x is more than or the same as 2, and then we are x is less than or the same as, so we're in this section here. So that's actually this little triangle that's in the middle. So what are the 3 values, right, that we could use, because we could be including all of these values. There's no, we could take this value here in the middle, right, that would be 2.5, 3, and that's not an integer value for r. So there's our region. All right, for all the reasons that I've said so far in the video, that's our region, right? And we're going to take each one of these 3 coordinate values that's on the points here, and I'll just highlight them with a different color maybe. So this coordinate value, this coordinate value, and this coordinate value would all work because in all 3 of these inequalities, because we're actually including those particular values on the line. So they are the ones that we're going to list, and I'll list them in the red. All right, so we've got 2, 2 is one that works. We've got 2, 4 is another one that works, and we've got 3, 3, which is another one that works. And we could check those out and make sure they do work, but they will. All right, you can check them out yourself. So please click the link in the description and practice this particular skill. It's just equations of lines. Don't get scared of it. It's a little bit tricky with the dotted lines and the shading in of the right areas, but choose your coordinate values, check your answers, see if they make mathematical sense. You've decided if it satisfies that particular those particular inequalities. Let me know if you want me to do something more on this one, if you haven't understood it perfectly, in the comments section. Like the videos if you liked the video. Don't like it if you didn't like it, but don't dislike it. What's the point of that? What's the point of having a dislike button anyway? Dislike it if you want. If it brings you joy, dislike it. I don't mind. But yeah, subscribe to the channel. Be one of the Bear Nation. Be one of the Bear Cubs. All right? Why not? Wouldn't hurt anybody, would it? Take care of yourselves. Bye.